Hi! In this week you practiced with inequalities and systems of equations. In this video you will see how these can be useful in an optimization problem. Suppose you really like these Delft blue cups and towels and you would like to sell them. Maybe making pottery is not really your thing, so you decide to make them with your 3D printer. Of course, you want your profit to be as high as possible, so you want to know how many cups and how many towels you should make. Now, you cannot make an unlimited number of them. There are some limiting conditions that you need to take into account. First of all, the towels and cups are printed with blue and white clay. Let's say a towel consists of 30% blue and 70% white, and a cup consists of 40% blue and 60% white. If T is the number of towels you make and C the number of cups, and if each cup or towel takes exactly 0.1 kilograms to print, the amount of blue clay you need is equal to 0.1 times 30% of T plus 0.1 times 40% of C. And in the same way you find the amount of white clay that you need. But let's say you only have 10 kilograms of blue clay and 20 of white. Then we have the following constraints. 0.03 T plus 0.04 C is less or equal 10, and 0.07 times T plus 0.06 times C is less or equal to 20. These inequalities say that the total amount of blue or white clay that you use is less than the amount you've got. To maximize the profit, you need to know what the profit is on one cup and on one towel. Let's say the profit on a towel and a cup is both €1. Then the total profit is the number of towels and the number of cups that you sell. So we need to solve the following problem. Maximize the function P equals T plus C under the constraints that we just found. How can we do this? Well, first we make a picture of all the inequalities. Let's start with the inequality for the blue clay. If we remove the less than sign, we get the equation of the blue line. Then all points T, C satisfying the inequality are below the blue line. Note that in the picture we also use that the number of cups and towels is non-negative, that is, T is greater equal 0 and C is greater equal 0. The inequality corresponding to the white clay gives the area below the white line. Now the points in the bright yellow area correspond to the number of towels and cups that you can actually produce. Next, we also draw lines representing the profit P. Suppose you want P to be equal to 100, then this corresponds to the line T plus C equals 100, which is the orange line here. The line corresponding to P equals 200 is parallel to the line corresponding to P equals 100. So you see that shifting this line upwards corresponds to making more profit. So you want to shift this line upwards as far as possible. But the line needs to intersect the yellow area, otherwise it corresponds to profit that you cannot actually make. So from the picture you see that the highest profit you can make, which is 300 here, corresponds to the intersection point of the white and blue lines. You can find the intersection point by solving two equations, and this gives T equals 200 and C equals 100. So these are the number of towels and cups that you need to make to maximize your profit. The method that we just used is an example of an optimization method called linear programming. In actual problems, for example in planning of routes for ambulances, there might be thousands of variables and conditions, but the underlying idea remains the same.